Welcome back to another episode of Tech Talk Today, where we delve into the captivating realms of technology and data systems. Today, we're unpacking the intricate relationship between data encoding and schema evolution, two fundamental concepts that can truly shape your data architecture. Whether you're a seasoned developer or just starting out, grasping these ideas is essential for building resilient systems. So grab your headphones and let's jump right in. Let's kick things off by discussing the advantages of using binary encodings that are based on schemas. One of the most notable benefits is their compactness. Unlike some of the more verbose binary JSON formats, schema-based encodings can significantly reduce data size by eliminating field names. This not only conserves space, but also enhances performance when transmitting data over networks. Another key advantage of schema-based encodings, they function as a form of documentation. With a schema in place, you can be confident that it remains current, as it's necessary for decoding the data. This is a substantial improvement over the traditional method of maintaining documentation manually, which often becomes outdated and misaligned with the actual data structure over time. Furthermore, having a database of schemas allows for a thorough examination of the forward and backward compatibility of schema changes before they go live. This is crucial for ensuring that as your system evolves, different components can still communicate effectively without causing disruptions. For those of you working with statically typed programming languages, there's an added bonus. You can generate code directly from the schema. This capability facilitates type checking at compile time, which helps to minimize runtime errors and boosts overall system reliability. Now let's shift our focus to how data flows between processes. Whenever you need to transmit data over a network or write it to a file, encoding it as a sequence of bytes becomes essential. This is where the ideas of forward and backward compatibility come into play. They're vital for ensuring that different parts of your system can evolve independently without necessitating a complete overhaul. So how does data typically flow? There are three common channels: through databases, service calls, and asynchronous message passing. Starting with databases, the writing process encodes the data, while the reading process decodes it. If you're the only one accessing the database, you're essentially sending a message to your future self. However, in a multi-process environment, it's common for various applications or services to access the same database at the same time. This is where backward compatibility becomes crucial. If a newer version of your application writes data that an older version later tries to read, you need to ensure that the older version can still decode that data without any hiccups. Let's consider a scenario where you add a new field to a record schema. If the newer code writes a value for this field, the older version of the code, which doesn't recognize the new field, might inadvertently overwrite it when it updates the record. Ideally, you want that new field to remain intact, even if the older code can't interpret it. This highlights the importance of careful data handling at the application level. One of the intriguing aspects of databases is their ability to store data across various timeframes. You might have records created just moments ago sitting alongside records that are years old. When you deploy a new version of your application, you can quickly replace the old version, but the data remains unchanged unless you explicitly rewrite it. This phenomenon is often summed up as data outlives code. While migrating data into a new schema is possible, it can be an expensive operation, especially with large datasets. Most relational databases allow for straightforward schema changes, like adding a new column with a null default value without needing to rewrite existing data entirely. Now let's move on to how services communicate with one another. The most common architecture involves clients and servers, where servers expose APIs that clients can connect to. This setup is prevalent on the web, with browsers requesting resources from web servers. However, the API isn't limited to web browsers. Native applications on mobile devices or desktop computers can also act as clients, making requests over the network. In a service-oriented architecture, one service may act as a client to another, requesting data or functionality. This approach is often used to break down large applications into smaller, more manageable services, allowing for independent deployment and evolution of each service. However, there's a significant difference between databases and services. While databases allow for arbitrary queries, services expose an application-specific API that restricts inputs and outputs based on business logic. This encapsulation is crucial for maintaining a clean architecture, as it enables teams to work on different services independently without stepping on each other's toes. When it comes to web services, two popular approaches are REST and SOAP. REST emphasizes simplicity and utilizes standard HTTP features, making it a favorite for cross-organizational service integration. On the flip side, SOAP is an XML-based protocol that comes with a complex set of standards, often sparking debates among developers about which method is superior. RESTful APIs, designed according to REST principles, have gained significant traction in recent years, especially in the context of microservices. The beauty of REST lies in its straightforwardness, facilitating easy integration and communication between various services. To wrap things up, understanding encoding and schema evolution is crucial for anyone working with data systems. By leveraging binary encodings based on schemas, you can achieve compactness, maintain up-to-date documentation, and ensure compatibility as your system evolves. Whether you're dealing with databases or services, being mindful of how data flows and how different components interact will lead to more robust and maintainable architectures. Thanks for tuning in to this episode of Tech Talk Today. We hope you found this discussion enlightening and that it equips you with the knowledge to tackle your data challenges head on. Be sure to join us next time as we explore another exciting topic in the tech world. Until then, keep coding and stay curious.